Almost late, but not quite. Almost. I was really close. I was really close to being late. I was doing a lot just now. Hold on, let me get the music going. Wow, when there's no music playing, it is noticeably silent. Noticeably. 1 second. How is everyone doing tonight? Welcome to a new week. Week 3 of Decoded. Let's get some royalty-free lo-fi, as we usually do. Let's start somewhere in the middle of the playlist. Let's get around. Let's try this one. Make sure, there we go. Coming through. What's up, Phantom Way? What's up, Nuke for Fun? Ball Clap, how you doing? Molo. Glad everyone's looking forward to learning that. We're gonna learn some good stuff tonight. Uncle Bill Drewin, or Drowin, how you doing? YGBSM, good to see you. What a great night. The greatest Rob, Mickey, 88 Opus, good to see you. What's up, Jess Machine? Back again. I see you just love to learn. I see, but that's pretty dope. What's up, Meow Mukes? How you doing, Zakar? Can't find the curriculum anywhere. The curriculum's not. Oh yeah, last night we shared the. Last night we did share the. What is that class called? Horizons curriculum. I will share this one as well. It is in Notion. It is not on the website. The only reason I didn't get it on the website is because I was trying to do UX and UI right. I was supposed to get a UX designer to kind of help me with some stuff, but I didn't know where to put it that made sense. So I'll just share with you what I have inside of Notion. But tonight we're gonna be learning all about data types. Yes, I'm gonna send the Notion link. I'm actually gonna make it a chat command tonight because I only made the other one. Actually, I'll just share the entirety of the curriculums. 1 second, let me make it public. Right now, there's nothing in them though, except for I think I put the slides, links to the slides in them, but that's it. I don't even think I put it in all of them yet. Here we go. Share to the web? No. Is that what I want? Yeah, I want share to the web. Anyone with a link can view. Copy link. Here you all go. This is what we're following. So here we go. Yeah, but tonight is going to be a lot simpler. Hopefully, first off, hopefully you recovered from last week with all the wildness. I understand. You know, we said it would be tough. I posted at the beginning of the week that it would be a tough week, and it was in fact a tough week for every single class. Yesterday Horizons, I think the pacing was a lot better for yesterday's class of Horizons. I hope, and I think today will be the same. I think today will be a lot more approachable than some of the things last week, and I think we'll be able to take our time and kind of get through stuff. I'm going to. Nope, I'm not gonna say it because it'll be wrong if I say it. So it should be a lot slower, a lot more comfortable. We can take our time a little bit. We don't have to get started immediately. Give people a chance to, relax, get in, get comfortable, learn a little bit about some data types tonight, which is a very exciting part of our coding journey. We've already touched on it a little bit, but we'll be learning a lot. Just getting set up here. Yep, not gonna say it. I know better. I mean, usually I know better, and I usually do it anyway. But today I'm gonna, show you a little bit of my maturity. Appreciate the host, Jets Machine. Can I get the Horizons one too? Yeah, you can. Let's make chat commands out of those right now, actually. So, what's the best way? I wish I could make these all in one command for, like one curriculum command. I can. Let me put it together really quick. Let's do that first. That's the first thing we're gonna do, just so people can get the curriculums. What am I looking for? Notepad? No, not Notepad. Keep. We want. I just want to grab 2 links really quick. Copy this link. I'm not looking at the chat right now, so if you're talking to me, I'm sorry. I'll see you shortly. Multitasking isn't my I can do it sometimes, but only with some things. Share, copy link. There we go, that one there. All right, exclamation point, commands, commands add, exclamation point, curriculum, and then I want that to return horizons space this one, and then I want it to be a couple spaces, and this is decoded, and that's gonna return this one. Now they might be backwards. I don't think they are. I know you can't see what I'm doing. All right, so now if you type in curriculum, exclamation point curriculum, it should give you the stuff that you need. All right, so Academy View, let's get the slides all pulled up nice and ready for tonight. Let's see. Is that spelled curriculum right? It should respond. It says it was added. Oh yeah, it came up. Now I don't know if those are right. Decoded. Yes, they are in the right order. Oh yeah, cooldowns make sense. All right. We are moving on to data types tonight. And share. Everyone can view. Anyone with a link, save, copy link, copy, 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 copy. You got to hit Control C a bunch of times. It's a necessity. If you're not doing it, you're doing it wrong. Just to make sure you copy what you needed, but you only need to paste one time. Nightbot mod or VIP, so they don't have cooldown. Oh, okay. All right, learn something new there. All right, so VIP. Actually, I don't know how to kind of just do mod and then Nightbot. Is it that easy? It says Nightbot's already a moderator though. Let me make him also VIP. All right, Nightbot's now VIP. Yeah, I don't know anything about those things. All right, let's get started so that everyone can ask all the questions you want to ask. We can go through as many examples as we want to go through, and we're not going to be held up by time. So tonight we're going to be talking all about the dankest of data types. Now, I'm sorry, I know dank is normally used to refer to things that may be illegal in some states and maybe not illegal in other states, but it's also a great word to describe excellence. And we're all about excellent data types. And you're my type. You're all my type. Don't tell my wife. It's okay. She won't know. But types. We've touched on types before, and so far this course we've been using different data types over and over and over, but we didn't really dive into what it meant. We don't really know the full extent of data types. We haven't got our hands on them and really dealt with them. So tonight, that's the goal, to really get you introduced to these data types. So data types are in fact types of data that programming languages use, and they present information in different ways, and you can interact with them in different ways. And that is what we are about to learn. So some of the common ones that we've already talked about are strings, which we said are lists of characters. So think words, phrases, list of characters, more than one character. What did I tell you should think of when you saw a string? What do we say you should think about? Or what's the visual representation of a string? How do you know? What's up, Cyber Barbie? In early with the raid, right on time. We just got started. Shout out. What's up, Raiders? How y'all doing tonight? We're just getting started, so you're right on time. We are literally on the very first slide. And did I actually share the slide link? Yeah, I did. We're on the very first slide tonight. We're learning all about data types tonight, not just in a particular language. We're going to be learning about data types as a whole, primarily focusing on Python. We're going to be learning some things in Golang as well. First off, actually, another little last week was a good week of learning. So what I want everyone to do is, if you're just learning how to code, right now. We're going to go through all the examples first in Python. We're going to focus on them in Python. So there's going to be concepts that cover more than just Python, but we're going to focus. I want everyone who's brand new to really focus on the Python ones and focus there. And we're going to use the Go examples to kind of cement in what we learned, but I want you to only focus on the Python stuff because it'd be pretty confusing. Now, if you're someone who's trying to learn Go, feel free to focus on Go instead. But for the true beginners, I want you to really focus on the Python aspects of things when you're writing the code. When we're writing the code and you're practicing writing the code, do it in Python. I think it'll be a little bit easier for people to follow along instead of trying to do it in both. But I think it's going to be important for us to see examples in both to hit home the concepts. What's up, everyone? What's up, Dev? How you doing? What's up, Lita? Good to see everyone over here now. What's up, Mini Flames? How y'all doing? Okay. Again, thank you so much for the raid. Everyone check out, like, seriously, I was just over on Cyber Barbie's channel right before my stream. She's working through some cool stuff in Python, learning Python, picking up new tools in Python. And yeah, it was pretty dope, kind of working through problems. And, you know, we're all struggling together on some stuff. You know, every day is not perfect. I know you struggled a little bit today, but you got through it. And it was a very momentous occasion when we finally figured out what to do. So that was pretty dope. It was pretty cool to see you stick with it and persevere kind of through the problems. So that was pretty dope. So we're gonna be doing all that in a few short days. To be honest, we're gonna be doing the same stuff, struggling through problems ourselves. But that's the fun in all of it. But cool. So you're new to it tonight. Focus on Python, even though we're going to be doing more than just Python. Focus on the Python piece of it. All right. So strings, list of characters. Whenever you see those double quotes, that's when you should be thinking of strings in just about every language. I'm going to say double quotes right now. There are languages where single quotes work as well, but there are other languages where single quotes mean something different. So right now, when you think string, think double quotes. That's whenever you see those quotes, you should be thinking string, list of characters, words and phrases. Then we have those integers, which are the whole numbers. Integers are positive and negative whole numbers. Whole numbers being, you know, complete numbers 1 or 2 or 3, no 3.5 or anything like that. Booleans, true or false, and then floats are decimal numbers. So integers and floats are two different types of data in just about every programming language. Now, that is what we've gone over already. We've talked about these things. We haven't dived super deep into them, but let's do a little bit of types continued. So here's why, again, I like to teach both of these together in the kind of intro to software class. And this is why when you're getting a computer science degree or something, they don't focus on a particular language. You'll have classes in a lot of different languages because, again, the concepts are vast. So if we were only doing the Python course, so if we just did a 12-week Python course before this, we didn't cover these things on this page here, but these are other data types, and they're more, some of them are more specific. We're adding on to the data types that we have. This is not even a complete list of data types, but these are some data types from Go, and they overlap. So Go does in fact have the things that are on this page. Python has the things that are on this page. All languages have the things that are here. These are kind of the base primitive data types that are available, but there are also other ones, and so Python doesn't have some of these, again, because of the way the Python works underneath. But there are other data types, like all of these are integer data types. And now take a look at the numbers that you see on the back end of int. That should start to seem familiar to you. Remember we were talking about bits and bytes. Those numbers signify bits. You see the 8 there. 8 bits is what? It is a byte. So these represent the amount of data that each of these can hold. So you do have a data type which is an integer, but an integer data type is actually an alias for, I believe, int32. So whenever you type in int in Go, it's actually referencing this. So why would you have different types of integers? It's for whenever you declare those variables that we were talking about, it takes up some space in your memory. And this allows you to tell the computer how much space you need. So, once you get to a number that can't be represented in a single byte, then you need an N16 so that you can put more information in there. So these each allow you to make a larger and larger number. So I mean, you can just use, you might say, why can't I just use the biggest one? You can. But when you get to bigger programs and things, and you care about memory management and you care about performance and things, these things matter. So it's just good to know about these concepts, that you do have other options available to you besides just the integer. But this is the data size. Again, bytes. This is a byte here, 2 bytes, 3 bytes, 4 bytes. Well, not 3 bytes, 2 bytes, 4 bytes, and so on. So the uint right here is also the same thing. These are integers, but these are unsigned integers. And what does unsigned mean? It means that they don't have a sign on the front. So it means that they go from 0 up. They're only positive integers. So the difference between an integers can be are their whole numbers, positive or negative. So -20, -21, -50. Uints are unsigned integers. There's no sign on them. They're always positive. So 0 up to whatever, and they have mirrored data here. Good concept to know. Right now we likely will not do anything with unsigned integers. Don't sweat it. Really, let's go back. Really, focus on these, but know about these. And again, a lot of these are subsets of the ones on the front. Byte. Check this out. This is in Go. These are all Go data types, but they're also data types in other programming languages as well, particularly other statically typed compiled languages, again, like C, things like that. But byte, a byte is an alias for uint8. So you might say, a byte is a number. So a byte is, a uint is an integer basically. So it's a number. And the reason that is these are, we'll dive into that. Actually, we'll dive into that a little bit later. But a byte is an alias for uint8, but it is a data type here. Same thing for runes. So runes in a lot of languages are just characters. Other data, I think Python actually uses character like char or chr as a data type as well, but runes are a character, and you can see it's an alias for an int32. Now I want you to think about what we talked about that day when we learned about bits and bytes and binary. We learned about something else. We learned about encoding, and we learned how ones and zeros can start to represent data, can start to represent words and phrases and other things. And the reason why a letter, so rune is a character basically, the reason why it's an alias for an integer is because, remember that ASCII table? Remember how, the letter lowercase a or something can be represented by the number 91 or something. I don't know what the number is, but that's why it's an alias for a number. That's why a character here and a rune is an alias for an integer to help you find that information out. Represents a Unicode point. So I have that right here. So yes, UT8. Yes. So you can configure the encoding. You can actually tell Go what the encoding is, but yes, by default, I believe it's UTF-8. So good question. Then we have floats here, and again, same thing. Floats, we said floats were decimal numbers, and we're gonna touch all these things. We said floats were decimal numbers, but you also have float 32 and float 64. Again, this has to do with the amount of data these hold, so the how big the number can be. And we're not gonna worry about complex, but these are numbers as well. When things get a little bit bigger and you're doing more computational heavy things, not important that you know all these, simply important that you understand that there are more data types than just these here, just the basics ones that we're going through. And again, also to just start to combine a little bit of your knowledge, that bits and bytes stuff that we learned about, the encoding things that we talked about, these all fall into those same lines. So you can start to make some connections between those things. But again, focus on these four, and we're going to learn about how these four play together with different things tonight. So first, let's see some examples of all of these things, and then we're going to talk about how you check types and how you see what type something is, because that's super important. So I want everyone, if you already have your dev environment set up and you have Python installed, I want you to, you can open up VS Code, and I'm going to do stuff through there. But if you do not have it installed and you're still having trouble with stuff, again, just head over. Don't even worry about getting it running right now. That is getting your development environment set up. We're actually gonna, like I said, I'm actually gonna record videos and have I'm actually going to record instructional videos for all operating systems and start to have that as a prereq for the class to kind of get people up and running before the classes start so that we can cover more of the actual coding concepts during the course. But head over to repl.it and click the start coding box and you can practice in here. You're not losing out on anything. You're not losing out on anything at all. You can type everything that we're doing here. But if you do have your environment set up and everything's, you've already gotten everything working and you're starting to have an understanding of how to run the code, I do want you to do it locally on your computer, just to kind of get that muscle memory down, to start understanding, start to feel what it's like to run the code locally yourself. So just no one stress about it. Just head over here if you want to, or even if you just would rather use this, go ahead and do that. But I would recommend doing it in VS Code or something. So what I'm going to do is I'm going to get VS Code open right now. And I'm going to do it from the command line. I think if you have a Mac, you can't do it from the command line, but you can just, click on VS Code and get it opened up if you'd like. And just make sure you open up whatever directory you would like to do, that you would like to work out of. So once you get it opened, open up, go to file and, open folder or open workspace and open up wherever you're going to want. We're going to create a few files tonight. Open up that space. But you can also do this from the command line. And again, like I said, I think it'll work on Linux and Windows by default. Mac, I think you have to run one extra command to get this to work, but I'll try to show you what that is. I'm going to go to the directory that I want us to use. So let's just practice some of those Linux commands a little bit, the Linux navigation commands that we were using a little bit. Do you use VM? So virtual environments, depends on what I'm doing. We're not going to be doing any Python virtual environments here. That'll be really confusing. But I'm going to CD into the place that I want to go, which is in my documents. I have a folder in my documents for deCoded. And then in here, I'll go here really quick. And I'm going to make a new directory here. So I'm going to make a directory called DataTypes. Data_types with that mkdir command. I think we learned that one, I believe. So it's going to make me a new directory. And it's right here. And I'm going to go back. I'm going to go into that directory just so now in my terminal, I'm in this location. But wherever you are on the computer, if you want to open up your Visual Studio Code, again, on Linux and Windows, you can type in code. If I just type in code, it'll open it up. And code and nothing else, it will open up VS Code. For Mac, if you hit Command P, do a little caret, do a little right arrow thing right here, and type in start typing install, and I think it'll be like there's something that should pop up that says like install VS Code in path or something. I think that's how it comes up. Maybe I can find you a better thing for that. I'm just not on a Mac, so I don't remember what it is. And that will allow you to type in code to like open up VS Code from the command line. But if you navigate to your directory from here, like if you wanted to do everything from the command line, once you get to your directory that you want to start working out of, you type in code space dot, and that says, hey, open up VS Code right here. Open it up, relative to right here, so I can start modifying things. So you can see here that I'm actually, it kind of went away, but I'm actually in the data types folder, and that's where I currently am. So again, open it up. You don't have to do all that. You can just file, open folder, wherever you want to do your work at, and get going. So let me know, are we all good? We're all there? Anyone have any trouble getting to that point, or like I said, or just click on repl.it. I'll update, since I'm not a VS Code user, but I'll I'll do it for the team. I'll take one for the team here. So go ahead and click your little plus here to create a new file. Call it whatever you want. I'm going to call this file I'm going to call it types.py. So types, the Python files end in .py. So I'm going to call it types.py. But if you want to do it via the command line, if you want to learn some of your Linux skills, hit hit control tilde. So the little squiggly line that's near your escape key, and the same key as the backtick, hit control tilde or hit terminal and then new terminal right here, and your terminal will come up. And now let's go ahead and let's use our Linux commands to go ahead and create a file for us to start working out of. And the way that we create an empty file for us to start working out of is the touch command. So we're gonna do touch space and the name that you want to call it. It can be called anything. I'm gonna call this types.py. All right. Now if I do types.py, check this out. It pops up over here immediately because I created a file via the command line, and it basically is going to populate over here because this is your file explorer. So I have a file here now, and now it's over here, but we're just practicing. You don't need to do that. You can do it right here. You can hover your mouse over this part here and click new file, or you can go to file, or is it edit, or the file, new file. So file, new file, and that will open up, and you can give it a name and it'll create a new file. So are we good? I'm gonna switch from Notepad++ to VS Code, and it's comfy. Yeah, I do like VS Code. This will be new for me. I just use Vim. Yeah, so I'm a Vim user as well. If you use Vim or Nano, VS Code will be pretty simple for you. You probably like it a lot, actually. Still use IntelliJ for Java though. Yeah, I really like JetBrains products for certain things. So what's the sesh command for Windows? It's more like it's like an echo, like a redirect, like types. Let's Google it. Let's have a little fun here. I know I actually think it's in the slides, but touch command Windows. I think you have to like echo out a file or something, but Windows equivalent of touch. Yes, echo dot. This is the way I know how to do it. You can also do this. I'll paste that in the chat so you can copy and paste if you'd like. So yeah, you can type that in and change your file.txt to py.null or whatever. So all touch does is it creates an empty file. So didn't need to do that. Just trying to teach you some Linux commands. Yeah, just trying to teach you some Linux commands because we do need, whoops. That was, well, that's fine. I created another file, but rm-r, I'll just type. But yes, just it creates a 0-byte file so that you could use it later. Not necessary at all. There are times when you do touch things, but not really for programming. Sometimes you'll need to touch a file before, like maybe you're writing a program that's outputting logs, like it's logging some information about what's going on. It's logging it to a certain file. Maybe you'll need to use the touch command to do that. But like really, whatever language you're using will probably give you a method for creating an empty file so that you can do that. But just adding to the tool belt. You can install Vim extension into VS Code to control your text. Yeah, you can. There is a Vim extension. It's pretty cool. Actually, maybe I'll enable it. The problem is I forget that I'm using Vim key bindings. Let's install it. Nah. That's gonna confuse you. It's gonna confuse. I'll be doing stuff and it's gonna make it confusing. But create the file and then get it open over here. And let's take a look at the data type. So we're gonna do. I'm gonna put a comment up top. Remember, you can put comments in coding files, and in Python it's done with a hashtag or ampersand or pound sign. And I'm gonna say we are playing with data types, just so we know what we're doing here. If we ever go back to this, don't show this again. Get out of my face. All right, so today we're playing with data types. And let's start with just some of the top ones that we just talked about. And just so we can have an example of them, the first one we're going to do is, here is a string. And a string, we're going to set it to a variable. We just learned about variables. We're going to set these to variables. So I'm going to say an example of a string. Actually, that might be a reserved word. I'm not sure in Python, but let's go. We always do name. Let's do something more fun. Let's do Nickname, sure, same thing really, but a string for nickname would be, again, like Aaron. We can say it's a nickname, and you can see here in VS Code, you get that typed out, you put your cursor right over here. Oh, maybe I have to save it first, but it should. I'm gonna save it really quick. Oh, really? Oh, it does it over this. So if you put your cursor right over top of the variable name, it tells us right here, str. It tells us it's a string. So VS Code knows what kind of data type this is, and again, it knows because of these quotes that I put around it. That is how you say it. I mean, that's how you tell it that. Okay, so pretty simple. And again, anything that's going to be inside of these quotes is going to be a string. I can type in whatever I want it with spaces, all that other stuff. It's going to read it in as a string. So let's do a number. So let's do an integer, just so you can see what everything looks like. Integer is going to be what should our integer be? Money in bank account is going to be our variable. So we're going to talk about how rich we are, and we're going to put $14 because that's how much we have at any given time. So money in bank account is going to be $14. Now we highlight money in bank account. Check that out. It says int. It knows it to be an integer. All right, so that is a number, and you can see that VS Code will even start to change the colors. Now your colors aren't going to be the same as mine if you are not using the same theme that I'm using, but VS Code does that. It starts to highlight these things so you can visually see the differences between your data types, and it actually, as you start to do more and more, it's actually a great way, like the way your brain works, like it starts to pick those things up really easily and really nicely. So it's pretty cool. It starts to give you indication of errors and everything. What's up, Rolls Roos? What's up, Mellow Mike 420? What's up, Ted 209er? What's up, Insane Samurai 92? Good to have you. What's up, Many Flames? All right, I already said what's up to you, or Manny Flames, sorry. Appreciate the follow. El Crypt ID, yeah, you know what I'm talking about. Welcome to the channel. Wolf from PDX, Mary Eleanor. I think all of you came in from the raid. Welcome. Okay, that's your integer. Let's do our float, because we're gonna keep this as the number section. We'll do our float. Our float is gonna be money. Actually, let's say money in checking, $14, and our money in our savings account, this is gonna be $4.60. All right, a little bit better. So it does, in fact, all about Tree Fitty. Yeah, I like the memes. I like it. Perfect. I love you all. I love you. So 14 for the integer. But check this out, it is in fact a different data type. It is in fact a float. So, it's got the decimal point in there, makes it a float, keeps it the same color because it is still a number type, but it makes it a float. So, and then the last thing we're gonna do is a Boolean value, very important value. And this variable is gonna be called, am I broke? True. I have a total of $17.50. So absolutely, I am broke, and that is of data type bool. So those are kind of the four main ones that we've discussed on the first page. We're gonna mess with these. We're gonna learn how they work tonight, what you can do with them. There are more slides talk about what you can do with them, but I wanted you to see what they look like. But let's also see how they're printed out. So let's print all of these. Let's display them to standard output. So we're gonna print nickname. Let's actually do. I should enable Vim key bindings because this is weird. We're gonna print out nickname. We're gonna print out money in checking. We're gonna print out money in savings. and we're gonna print out am I broke and just see how they print out to the screen. And we'll save this file. So we got a file with our main data types, and then we're gonna print them out to see what they all look like. So you can click the thing here, or you can open up the terminal again. So you can terminal, new terminal, or control tilde. And you can do, let's clear this. And the way that you run a Python file is Python, and this is most coding languages. You use the tool, so Python or Python 3, depending on your computer. So Python 3 is probably pretty safe. Python 3, and then the name of the file, which is types.py. It's gonna go through, it's gonna print them out. And so they all look the same when we print them out. So print doesn't necessarily care. It kind of just spits it out to standard output. It really is standard out that doesn't care. So it just passes that information to our console, and our console gives it to us. So just like that, we've printed out all those different data types. So commit these to memory. They're very, very important. I think if you have a good handle on these 4 data types, you can get moving and onto a lot of things. Like you can really start to do things if you have a good handle on these data types here. Now, you can play with that if you want. If you want to change those things up, you can play with that a little bit. Let's talk about the slide that was up there last, which is how do you check the type of something if you're not sure? Maybe you aren't using VS Code. Maybe you're not using VS Code, and you can't just highlight it and tell you. The way that you check the type is there is a function. There's a function called type, and there's a function in Python. So this is different. This is done differently in Go, and I'll show you how it's done differently in Go. But if you want to check the type of something, I check the type of nickname. I check the type of money in checking. I check type of money in savings, and I check type of am I broke? All right, so now these are not print statements. These are type, these are the type function. And if you highlight it again in VS Code, and you can probably see here, it says class type object, but it says the object's type, name, base, dict, a new type. Maybe that's confusing. That's actually really confusing. But usually when you highlight a function definition, it will tell, well, when you highlight a function name, it'll tell you what it does. So this tells you kind of what it does, even though it's hard to understand. But let's open up a new terminal again, and let's run our file again. Whoops. Okay, now actually this is great. This is excellent. We ran the file and nothing happened. Can anyone tell us, first, what do we expect to happen? We expected to see what types each of these things were printed out to the command line in front of us, to the console in front of us, but they did not. Can anyone tell me why the program did nothing? Well, actually, I'm gonna give you a little hint. The program didn't do anything. It did exactly what we told it to. It did exactly what we told it to. Yeah, there we go, Slime. Yes, so it is, in fact, when the program runs, it is interpreting these lines, and it is in the program, it is identifying the type of these things, but we can't see it. We can't see it happen because we haven't told the program to show it to us. So we need to print this. So that command that we learned, the function that we learned to get things out to the screen, we need to put a print in front of all of it. And I really wish, oh no, I really wish I was using Vim right now, because then I could just more easily do this. Or maybe someone can throw me some keep shortcuts for VS Code, because this is frustrating, actually. Ugh, stop popping up. That's really annoying. Okay, save it out. Type doesn't print to the output stream on its own. Correct. So this function, you haven't learned about functions yet, but this type, the tool that they give you, type, to be able to find out what type something is, it does not print out any data. It does in fact do some stuff, but it doesn't print out any data. So you need to tell the computer to print that data out. And so we'll run it again. And now we do get some printout, and it looks a little weird. You probably haven't seen anything like this. You can ignore this class thing. We're gonna learn about classes. But the first one, nickname, is in fact a string, and it tells us it's a string. Second one's an int, a float, and a bool. So this is how you can tell the type of a variable or of a piece of data in your code. You can use this type function here to do exactly that. Now, let's see this in Go a little bit as well, just to again show you how similar it is. But what we're focusing on in this section is there are a couple different data types, which we've already talked about before, but just seeing kind of what they look like. A number's a number. What happens if I do this? Is this still a number right here? Is the 14 still a number? And let's print and see. If you weren't sure, just run this again. And now the second one moves from before it was an integer, now it's a string. Again, whenever you see those quotes, it is now a string. Very, very important. Very important. What happens if you just put one here? Who knows? Let's find out. Uh-oh, we have an error again. You gotta close. You can't just put in what you want. Like, you got to make sure you put all the pieces it needs. So basically it gives us an error because it sees one open quote and it doesn't know what to do kind of with that. All right, so let's turn this back into an integer. All right, I'm going to open up another, I don't want to do this here. Actually, yeah, I do want to do it here. And we're going to mirror this file. And right now we are going to open up a types.go. And you need package. You don't need to do this piece. Just again, I just want you to submit the concept. So import, what do we need? Import funct, and we need func main. All right, so this is just kind of everything that Go needs to run this skeleton code right here, but same thing that we just did over here. Let's actually close this side by side, close this, types over here, same thing that we did. Let's do it in Go. All right, we need to do a string. So here we want to put a comment here, and this is going to be how we do a string. And we're going to go nickname equals Ron. All right, so looks pretty similar to this, except we have this walrus case. And again, remember, actually, we could do this in a couple different ways. I could actually put a thing here. I think I could put string here if I wanted to tell it exactly what type it was. If you weren't sure, there are times when it will interpret things wrong, and it will infer the type incorrectly where you can put it there at the end. But you know, we're gonna keep it as simple as possible. And now let's do an integer. And we'll do again money in checking. We're gonna do the same. We'll keep the same numbers, 14, and we'll do a float, and we'll do money in savings, and we'll do 350 or 350. And we'll, last but not least, we'll do our bool, and we'll do am I broke, and we will do true, so I'm broke. I think it's all lowercase in. Yeah, there we go. Really annoying. Trues and falses and the way that they're identified is always different. It's always different between languages, so it's always pretty interesting figuring out, you know, which one it is. It's really annoying. All right, so really quick, we'll print these out. Actually, no, we're not even gonna print them out because we already know about printing things out. So the way that you check it in this is a little bit different. The way that you check it in, at least the way that I know how to check it in Go, maybe there's another way, but I think this is the best way to check it, is you actually are going to use the print function. So the function that you use to print things out to the console, it's built into that, and it's built into the formatting version of it. So we're going to do format.printf, All right, and so let's say we want to see nickname. We can put a remember we did those percents, we did, like I was doing percent V's. The way that you do this is percent T. I think it's either lowercase t or capital T. I always forget. You do percent T, I think it's capital T. And you do, then you give it the variable name, so nickname. And this is how you check the type of that. And I'll just copy all this and change it. Maybe it's lowercase v, v, v. So it's included in the print statement. Money in checking, money in savings, and am I broke? Again, yes. Maybe lowercase t. Is that better? I'll save that. Why is it unexpected percent? Oh, I'm tripping. Hold on. This needs to be in the T needs to be in quotes. So let me tell you why it needs to be in quotes, because this is immediately applicable to data types. So the print command, this print command, it's primarily working with strings. It knows how to work with strings correctly. Hold on, maybe that's better. No, that's not it. Hold on, what am I doing wrong here? I figured out a second. Money savings, don't use it. Never mind. Okay, different problem. Okay, so the reason you have to put it in here is because printf, this print command is trying to do things with strings. So if it's trying to put something out to the console, it's thinking words and phrases. So it's trying to work with strings here. And this function actually takes in strings. So this has to be formatted as a string. Again, not important that you know how to do it. Just whenever we're thinking about printing things out, generally you're going to be wanting to work with strings. It is a problem that we're going to see tonight, that you might have to make sure the things that you're working with are in fact strings and not a different data type. Strings are the type in which you use to output information. So right now Go is telling me, it's giving me a little bit of a warning, and this warning is basically saying, hey, in Go, we don't want to actually use underscores in Go variables. So this has to do with, like, this will work, I believe. Pretty sure this will work, but it's something that they don't like us to do. So let's run it, and then we'll switch it up to make sure it's right. So go run types.go, and check this out. It's all side by side, but we got string, we've got int, we've got float 64, and we have bool. So look at this order. We have a string that was first, a integer, then a float, and then a bool. Now, why is it like that side by side? You might say, that's dumb, like Go's stupid, like I don't really like that. Why is it side by side like that? It's like that because this printf prints out a single line. Remember, we learned a little bit about print versus print line. This print just does a single thing. So to get a new line, we can just simply add in a new line character. So we'll do this on all of them. And again, see, you might say this is a lot more complicated. It is. And the reason why we're covering it is because these rules, all these new rules, they're things that are good to know. They're things that'll make you a better developer. So it's kind of good to know. So let's also make these a little bit better. There's a couple different ways to name your variables. I think variables always have to start with a lowercase. I don't think they can start with an uppercase. It depends on the language, but I don't think in either one of these languages, I do not believe a variable can begin with an uppercase letter. It's got to start with lowercase, but you can do some things like camel casing. So over here, you can see this was fine. This is called snake casing, I believe. So when you have different words connected by underscores, I think that's called snake casing, I believe. If you did something like this, now, I don't think you can do this in most languages, to be honest, but this is called kebab casing because imagine a shish kebab. So the dashes are the lines going through. This is called camel casing. Might be called like Hungarian notation or something as well. I think it's called something different so I think it's camel casing if the first letter is capitalized. I think if not, it's something else, but whatever. Most people refer to this as camel case a lot. So usually you'd use a convention like this in some languages. So we'll just do that here. But again, a variable is just a representation of data. So like, it doesn't matter. It doesn't matter what this is. And it kind of gets weird here when there's you know, that one's a little bit weird. But yeah, now all of our warnings go away. But then we would have to change all these down here, which I don't feel like doing. But just wanted to show you, want to run through some random stuff. And kind of, again, give you more and more little tidbits. Now you've heard some other things. You might be like, again, write it down. Write down, I said camel case. If you're like, what is he talking about? Write down camel case, write down kebab case, write down snake case. Start to look these things up, because sometimes people will tell you in interviews, in coding interviews, I've seen like part of the parameters instructions say, yeah, make all variables, you know, camel case, make all variables this case. So pretty important. Pascal casing is a capital letter. Is a capital letter in the front? Yeah, there's probably a page we can look up for that. You just go run file name.go. You saved it. Cool. Back delete. I am back deleting my life away over here. That's fair. All right, let's actually, I will change these. Nickname's fine. Money and checking. It's also weird not using so the reason, again, let's take a look at my keyboard again. The reason I built this keyboard does not have any arrow keys, because Vim, I'm a Vim user, and Vim actually uses these H, J, K, and L to move left, right, up, and down to navigate. So when I'm in here, it's always super weird to like go to like move my arrow, move the cursor around, because to use arrow keys, I have to hold this key and then hit one of these keys, which I've like mapped. So I have to like hold this and then hit these. And it's really annoying sometimes, but I'm getting more comfortable doing it. So it's actually a good, I don't know, it's adding to my muscle memory. It's kind of fun. Am I broke? Yes, I am. No money. All right, and so we ran it. Well, let's run it again just to make sure things are the same. Terminal, go run types.go. Okay, and you can see here, even the float, it made it a 64 by default. And let's say, so again, also in Go, because you can be explicit about those types. If I wanted this integer to be not just an int, and I wanted it to be like an int 64, I could in fact do that. Like, let's say maybe it was changing later. Actually, not do that. I would have to do it like this, I believe. Sorry, other side. Or maybe not other side. Do I have to do it? I thought I could do it on the same line. Maybe I can't. Maybe I'd have to do money and checking. Hold on. Var money and checking int 64 and make this just an equal sign. Because maybe you're doing some things throughout your program. And maybe, you know, the number is changing. Maybe this is your starter number, and later it's going to be much bigger than what can be held in int 32. So you need to make an int64. So you might have to do something like this and explicitly declare that data type. And so now if I do this again, you can see the integer is now an int64 because I explicitly made it an integer, a 64-bit integer. Yeah. So just a little bit of extra info right there. Okay. Any questions so far about the main piece of data type and checking data types? Again, the 4 main ones, just kind of seeing what they look like on screen, and then learning that you could check what type something is in a given language. So the reason why that's important is because now, if you're ever confused, if you're like, hey, I have no idea what data type this is, you now know. You can Google with whatever language it is. You can Google, if you're working with Ruby, you can say, how do I find out the type of what data type something is in Ruby? Like, you know that that's a thing that you're able to do now in a language. You know that that's a tool that you have available to you in programming languages, and that's why that's important. Take a look at it your first time. You know, Python makes it easy. The word is a lot simpler. This is a lot simpler, I think, than this. This is pretty confusing if you're first looking at it. You know, symbols can be confusing. We know what this word is. That makes sense. Want to know the type? Type in type. But yeah, hopefully we're good there. You got variable not used. So getting variable not used, oh, you saved it. Okay, perfect. Yep, that'll do it. Trying to keep up, but the tag mgn is based off signature for someone. Oh, okay. All right. So let's head back to this. Let's head back over to the slides really quick. I am gonna push these up to GitHub a little bit later, so you can pull them down when we're done with this. But just again, take a look at them. Just get your eyes on them. Two different ways, two different implementations of the exact same code in two different languages. They look similar. And again, I'll actually remove this because we don't need this. But it done in a little bit different way. That's great actually. Noah, thank you. So Python is kind of taking on the same approach. I like that. Well, it's the same thing. I'm getting used to the printf, because the printf will, right now, because you can just print this, but type inside of the, that's actually very similar to this. It's actually the same thing. Actually, I like that. See, Python knows that Go's got some good stuff in it. That's a paradigm. So I guess the new paradigm is like this: F, and instead of calling the type, that's interesting actually though. So instead of calling the type, does that work? That's interesting. It's the same thing actually. It's the same thing. But it is it's the same concept of this over here. Let's make sure that still runs. Did I do that? Oh, whoops, the wrong, oh, quotes. Yeah, that makes it the same. If this works, that does in fact make it exactly the same. Oops. Okay, interesting. That is a good paradigm to know. Let me put that in my things that I learned this week. Copy. Oh, I don't think you guys know about this. I'm keeping a list of things that I learned this week on stream, because you all teach me so much, and that stuff is super valuable. And I would also like at the end of the week, I'm going to figure out a good format for this, but I want to share the things that I've learned. And just so you guys can kind of see what I've learned so far, yesterday I learned that how you align. I'm not a web developer, but I learned that you can align text based on its the origin of the text. So if you're Arabic or Cantonese or something that is right aligned, you can set the dir equals auto option inside of whatever HTML tag it sits in, whatever section it sits in, and it will automatically check it and align it properly. I thought that was pretty cool. I learned about the Caddy web server, which is a Go based web server. I love Go. I do a lot with servers, and it's cool. I'm gonna check that out. I learned that Windows 10 has SSH now. I learned that last week, but it's super powerful, and it's important to know now that Windows 10 does have SSH, so you no longer need to use PuTTY. I also learned that you can type CMD or PowerShell in the Windows File Explorer to open up a command prompt by that location. So let me actually show you guys that. If anyone's on Windows, you can do this right here. You can open up your File Explorer, which is shows you where your files are. You can kind of click around. Let's say I want to go to my documents. In your documents, if you wanted to open up your terminal or your command prompt right here, you'd click up top here, type in PowerShell or CMD, and it opens it up right there. That's pretty cool. I like that. That was something I learned. I don't do a lot of Windows development, but that was cool. And today I learned about Python 3's new implementation or preferred implementation of checking types. That's dope. Thank you very much. I'm having a hard time easily typing all these symbols for Go. Is there an easier way to do it? So yes, no, to be honest. You can, all the symbols for Go, nah, not really. There's not really an easier way. You can install some different plugins and stuff that will every time you Nah, actually, I was gonna say every time you do like quotes and stuff, it'll close them as well, but it already does that. Nah, it's the tough part. It's definitely there's definitely a learning curve for being able to write, like, to type that and write that. No real easy way that I can think of. Your function calls in there too. That's nice. That's actually really nice. What VS theme do you use? I use Monokai Pro. So just search for Monokai Pro over here on the left. It's really annoying because it costs money. I didn't pay for it, but if you don't pay for it, like every 20 times you save it, it'll pop up and be like, you want to buy this now? And I'm like, nah, bro, I don't want to buy this. I'm only using it because I can get it for free, and I'll use a different theme. I'm not really paying for a theme, but maybe if you love it, I say pay for it. I usually am a supporter of all softwares that I use, but because I'm a Vim user, mainly, I'm not gonna pay for a Monokai Pro theme in VS Code. Yeah, new Windows Terminal is in fact amazing. I use the new Windows Terminal even though it's in beta, and it is excellent. It will give Hyper a run for its money for sure. Is Ubuntu inside the VM? So yes, I'm running Ubuntu inside of a VM right now on my host computer. I usually run, I'm trying this out instead. So I have a Linux laptop. I have a System 76 laptop that I've been using to do the streams that I capture through a capture card. But I wanted to see if this will give me a little more flexibility to be able to hop in between Windows and Linux a little faster, and it has so far. So I might keep this up as well. So, but this is running in a VM. I use VirtualBox purely because I'm a fan of free and open source software. VMware, I've used VMware and it's good. Like VMware Player and stuff is in fact good. It'll probably work for most of your needs. So it's pretty dope. How come you're on VS Code if you normally use Vim? Because it's easier for people to follow. I told people to use VS Code if they were going to pick a text editor. It's going to be easier for people to follow me or follow what I'm doing if I do it in the same tool that they're going to be using it in. Once you all get to the intermediate, the journeyman course, and the advanced course, I will be using whatever I want. You will hopefully be at the point where you can separate and I get it in the apprentice course. I do think it makes sense. It does make it difficult to mentally separate the tool from the concept, and I definitely understand that. I think that makes a lot of sense. So I will be trying to use the same tool as everyone, the same tools I'm telling you to use in the apprentice level courses. But after that, we should be in a place where we can mentally separate the tool away from the thing that we're using and be able to follow along a little bit easier. So I'll be using Vim after that, just because yeah, maybe you'll be using Vim by then. What's up, Jumpin' Jacks? Good to see you. Welcome tonight. All right, so let's move on. Let's hop back into the slides and let's get through. And like I said, we're moving. If you feel free to ask as many questions as you want tonight. We have time. We're not going to be super rushed tonight as we were last week. Okay, this is an important concept, and this is going to be fun to practice a little bit right now. We're going to be talking about typecasting. Another word for it is type coercion as well. But you can cast or convert or coerce one data type into another data type. This is pretty important. This is something that you'll have to do often, especially in a statically typed language like Go. Why are you gonna have to do this? You're gonna have to do this sometimes for printing purposes. So sometimes if you try to print out certain data types, it won't let you. The way, depending on the way things are set up. Sometimes you need to make some modifications or include that data in something else. And you'll have to be able to do so. You will have to cast it to another data type. And let's see what that means and let's practice what that means. And there's a little bit of an example down here. And this is the act in Python of converting, and it's not even converting. I don't even want to. Yes, we are converting it, but this is not a convert. The word convert kind of denotes a permanent change. This type casting is like it's not a permanent change. It is doing a conversion, but it is not a permanent change unless you make it permanent. So we're going to see that as well. But this is taking the number 5 and using the string method or the string function to convert it to the string 5. So you see those quotes there? It is a different data type now. So let's go in and let's practice some typecasting and type coercion because it's pretty important. And you'll see here that it is in a statically typed language, it's generally a much more confusing to do. When you're first seeing it, you're like, man, that is, again, that's a lot. That's a big deal here. So let's get started with this. Yo, diarrhea. I'm gonna call you D. How about that? Yes. So that whenever you see Go saying a variable is declared but not used, it means that up here or wherever you put it, you set up space for a variable. So maybe you made money in checking and you set a value, but then you didn't do anything with it. So like, let's say I remove this line, money in savings line. Let's say I remove that line and I saved it. I'll get the same thing. It's declared but not used. If you declare it in Go, you have to use it. If you think that you did both, if you think you declared it and you used it somewhere else, check for typing. Check that you spelled everything correctly. But whatever you set up, you got to actually use it, or Go will not let you run the program, again, because it does all the compiling beforehand. During that compilation, during compile time, it's actually going to be opening up space in memory for these things, and it doesn't want to allocate memory to something that doesn't need to be allocated. So it's it's pretty interesting. So just to make sure it's being used, or if it's not being used, go ahead and remove it. Just remove it from here and everything will be good. And we're back to normal. But if you declare it, if you made a variable, you must use it in Go, only in Go. That doesn't matter. And that does not matter in Python. There won't be any errors. Dynamic languages, the reason why that won't matter, again, is because it does not pre-compile the code. It runs through and interprets the stuff line by line. So it doesn't even know that something hasn't been used because, it goes through and reads the file almost real time. D-Works, I've used it. Excellent. I've used it and the spelling checks out. Did you save the file? That's the last one. Did you save the file? And what are you doing with but did you try making sure you save the file as well? And then and let me know if you're still having problems. But okay, type coercion. So let's close these. Let's get rid of these. Let's start with some fresh files so our eyes have something simpler to look at. So again, let's go ahead and let's open up a new file. And I'm gonna call this I'm gonna touch casting. I'm gonna touch casting.py. I don't want to hear any jokes here. All right. So we got casting.py here. And we're gonna use this to cast types to different types. So let's add some what are these called? Comments up here. And let's start with a string. Let's try a couple different things. So let's do like string to int. Let's try string to, let's try all the different things we can do. So string to int, we got string to float. Let's try string to bool. All right, so those are all of our string categories. Let's do, and we're just gonna see how these work. You can't do all these, but we're gonna see how they work, and what happens when you try to do something you can't do. Let's try to convert a string to an integer. Let's try to convert an int to a string. Let's try to convert an int to a float, And let's try to convert an int to a bool. And then lastly, let's try to do actually float. Oh, there's so many options here. Float to int. Actually float to string. I'll paste all this in here so you can just copy and paste it, because this is you don't really need it, but if you want the comments here, float to string, float to int, and float. What's up, Hammy Ham Taro? I like Ham Taro. Ham to bool, and then lastly we have bool to string, bool to int, and we have bool to float. So we have half of 23 different options, 24 different options to do, 23 different options to do. So congratulations, we have half of that. All right, can you use couch as a var name? You should be able to. Damn it, you got me. You got me that fast. How did you? Oh man, okay. You know what? This is a PG stream. I'm not responding to that, and I'm gonna act like I didn't. I can't believe I walked into that. I should have got that immediately. But yeah, you can kind of copy that. That sucks. The formatting sucks. But let's try these out in Python only. So the way that you cast to new types is that Python, we can go check Python's documentation, but I'm just going to give you these now because, again, I don't care that you know how to do it in Python right now. I care that you understand the concept of doing it. So let's say we have a string, which is we're going to put print statements in all these just so it prints out, but we're going to say the way that you would do this is something like int to string to int. So the way that you would try to do it is to convert something to an integer. You use the int function, and then let's put in here, let's try my name, and let's see this first. Let's see what happens if we try to print this out. So by default this won't do anything, so we'll put this in a print statement, and we're going to try to print out int Aaron. What do you all think is going to happen when we try to convert my name of Aaron into the type integer? What do you think is going to happen? I hate you all. I loved you before. I said it to you on stream, but now I hate you all. But yeah, so let's try Python 3. What is this called? I'm changing the name from casting. Cool. So we get an error here, and we're gonna learn about errors way later than now. But we get something here called like a type, not like a type error. We get a type error here. Actually, this might not be it should be a type error, but it might. What happened? Where did I run it at? Why is it giving me all this? Hold on. It's gonna give that to me again. Why is it? I'm just confused why this is fine, but I'm not sure why it's okay. Well, it's giving me a value error, invalid literal for int with base 10. So basically, obviously you cannot convert you can't convert an integer, you cannot convert this string into this integer. It has no way to handle that. It's got no way to do that. It can't make that happen, but it can if the integer actually can be converted. So it's trying to convert it. It's doing its best to convert it. It'll do what it can, but it doesn't work. So, but if I do put an actual number in here, it can do that. So it does in fact print 5, and so this will convert it to the number 5. Now, let's actually put it in a variable. So let's say my age is 30. And I try to print, let's say first I print age. Let's say I try to print my age is, and then, you know, maybe you were trying to put the strings together like this, and you said 30, not 30, and it is age. You try to print out your age like this. And I try to run this code right here, and it's gonna fail. It's gonna give us a type error, you can only concatenate strings to strings. So remember, we talked about a concatenation, string concatenation, which is the process of combining strings together, so words and phrases together end to end. So putting words together end to end is concatenation. And so it tries to do that here, but it can't, because it can only do that with strings. Like the word concatenate only applies to strings. So when you want to do something like this is a time where you'd have to coerce the type. You'd have to change the type to something different, or try to cast it to something different. So this is where I would go string, even though I'm trying to do a string to an integer. So this is a bad example, but let's make it a better example in a second. My age is 30. Right here, it does in fact print that out, but maybe a better example will be this, that I put my age in as 30, and maybe I want to say my age is 30, but let's see, plus, but next year I will be age +1. All right, so maybe I'm trying to say my age is 30, but next year I will be my age +1. Maybe I'm trying to do a little bit of math here, and so this might be when you want to do something like this, a string to an integer. And if I try to do this, it'll basically say it can only concatenate. It's trying to concatenate this stuff together because my age is a string. But maybe I want to do something like this, int, and convert it to an integer first. And whoops, that is not what I meant to do. Can I stick it in there? I think I can stick it in here. I think I can do that. Maybe not. No, I can't. What am I missing? I'm missing something here. Or can I just not add it? Open, close, open, close. That should be fine. Can you not do math inside of a print function? That makes sense. Actually, I would have to do something like this. Sorry. Maybe you're trying to do this. Maybe you're trying to do next year. Next year age equals 30, or age +1. And you're trying to add the number 1 to it, but it's not gonna let you do it because you can't add a string and a integer together. But all right, so maybe you're trying to print out something like this. It's a dumb sentence, but you're trying to print out, you're saying, hey, my age is 30, and next year my age is going to be my current age, but with 1 added to it. And then you're trying to print out this statement here, and you try to print it out like this. And again, it's not going to work, but it will work if I do this, or should work if I do this, and cast age to a different data type. If I cast it to a number, it can add a number to it. I think this will work. It should work. Where is this? Can only concatenate, line 4. Oh, never mind. It would have worked. Hold on. I was right, I think. There we go. Let's do this. Let's put it back. Now I've confused everyone, and I apologize. Age. Will this work now? See, this is why reading is fundamental. It told me what to do. And I can see you guys typing in my peripherals. I'm figuring it out first before I do anything else. Can only concatenate string. What line is this? Line 4. Yes. So this makes sense. So act like this line is gone. And so now it's giving me the error. Can't put those two things together. But if I also do this, and not this. Wait, this is what I already did. I already messed this up. Hold on. Give me a second. Age is, but next year, cannot convert, type int. Bruh. This is a bad example. I gave you a terrible example, but yes. but age is already a string. I don't need to stringify it. Stringify the addition of stringify. Oh, this is a bad example. This is a double, like you're saying stringify the int of age plus 1. You gotta say it like this. You guys, this is terrible. Sorry, this is my fault. This is a bad example. This is a terrible example. Yes, this is right. I tried to think of an example on the fly. I did a bad job of creating an example on the fly. Take all this back. Take all this back. This works. This is too complicated. What you need to know, we're gonna remove all this. All you need to know is that to turn a string into an integer, this is how you would do it. You would do int, and you put the string inside of it. So Aaron, this, oh nope, it's got to be a number. So like 50. This is the only thing that will work. So this works, this doesn't. Int Aaron won't work. All right, there we go. Did a lot to mess all that up. No big deal. Let's back it up. We went down a rabbit hole. If you want to convert a string to an integer, this is how you convert a string to an integer. You put the integer inside of this little function here, and so this will work because it must be an actual thing that it can convert to a number, but it can't do this one right here. All right, we got this. Does that make sense to you? Do we have that part? That hopefully that's less confusing. This is why you don't think of examples on the fly. I thought I was smart enough to think of a good example on the fly, and I did not do that, and I'm sorry for the confusion. All right, so let's keep going. I just gotta type it. Yeah, it helps if you type it. And again, if you actually want to see it typed, you have to put it in a print statement and try to run it a few times. And so this will actually, you know what, maybe one better way to see it is maybe try this. Here we go. Try this. Let's say age equals 30. There's a better way to see it. I do think there's a better way to see it. So print your age, print type age. So print the type of age. And so we said we want to convert a string. So make your age a string, print out the type of it. So just so we can see what type it is. I'm gonna leave this in here. I'm gonna leave those here at the bottom as these things. So print that out. And so if I run this right now, if I run just these two lines, age equals string 30, and I print out that type, what am I gonna get? I'm gonna get print casting.py. Okay. Did I save this? Why? Oh, print. What am I doing? Python. Man, I'm struggling. Okay. It's a string right now. All right. It's a string. We're trying to convert a string to an integer. Check this out. Variables can be changed. So let's change it. Let's go age equals int of age. So what this is doing, this is taking a string. So right now age is a string and it's converted. Actually, let's do age casted or something. Age cast, just so it's not confusing. It's less confusing. And now print this type. So we're gonna convert age. Age is already a string. We saw this as a string, but now we're gonna convert it to an integer. And now if you type in, let's close this. Now underneath here, if you print out type of age cast, and you print this out, now you'll see when we run this, at first, the first thing is a string. So we know this is a string. But now after we use int, oh my gosh, the mouse is not working well in the virtual box. Let's lower this. After we cast it and we try to print out the type again, it is now an integer. So all we did was All we did was convert the type from one type to another. That's all casting is. Again, not important that you know how to do it, just casting one to another. This only works with a number. When you're doing it string to int, it's got to be a number. If I do, again, something like Aaron, this will all break because that doesn't work. This only works, you can only convert a string to an integer when there's a number involved, when the string is actually a number. All right, so let's go to the next one. Let's go to string to float. And so this is the same case. Let's actually copy the same stuff right here. We'll have to change it. Let's do string to float. We'll just change the variables. We'll call this age float, and we'll call this let's comment these out first. So when it's a float instead, a string, we're trying to convert a string to a float. A string, which is words and phrases, we're trying to convert it into a float, which is a decimal point number. So before we did it to an integer, now we're trying to do it to a float. So again, if you do this, let me comment out this up top too, because it'll print out too much stuff. This is the only code we want to focus on right now. We run this. This is going to print. This is the type of age float right now is a what? Age float right here is a string. And so we print this out. Let's make sure we get that. We get class type string. But if we want to convert it to a float, let's try to age cast again. And instead of int, we're going to type in float. Pretty simple, right? Makes sense. You want to convert an integer. You want to convert something to an integer, you use int. You want to convert something to a float, you use float. And so now we're going to try to do that again. We're going to try to do that and see what we get. And it is in fact converted to a float again, because it's a number. But I'm going to print it. I'm going to actually print it out so you can see what it looks like. Now, when I print it out, check that out. And that is, wow, this will not go away. Okay, check out that 50.0. Remember, floats are decimal numbers. So it converted this into this. Whereas if this was the integer, it would just print out the number 50. So you can, in fact, convert a string to an integer. You can go from word to number if the word is a number. If it's actually a number, you can convert it from a word to a number, whether that be an integer or a float. Again, that'll work as long as I keep this to be a number. If I make it 50.56, this will in fact work. But as soon as I change it to something else, as soon as I put other characters in here, it will no longer work. Now we get an error. So that is the only thing you can do. Now, what happens? No, we're gonna comment all this code out. Actually, I'm gonna copy it again, comment it out. Let's move down. Let's try to convert. Let's close this. Let's try to convert a string to a Boolean. So now we're trying to convert a words and phrases into a true or false value. So let's see what happens when we try to do it like this. So we're trying to convert this string. We still have 50 in here, and we know that it's a I'll change it so it doesn't really need to do that. So we know that this is a string. We know that this will print out a string because it's a string here. But to turn into a bool, we type in bool. Not the whole word Boolean, but just bool, and it will try to do that. And we'll put this inside, and let's see both what type this turns into and what it actually the actual value is. So check this out. It's a string, which then gets turned into a Boolean. And the Boolean becomes true. The actual value is true. This is a very interesting concept and something that you will be picking up over time. True false values can be very interesting. Truthy and falsy values can be very interesting in a programming language. But check that out. Isn't that interesting that when you we need to turn a string into a number, you can do it as long as it's a number. But like when you need to turn a string into a true or false value, you can do that as well successfully, and it comes through as true. Does it matter if it's a number or not? I wonder if it matters if it's a number. I mean, I made it, you know, it's still a string, but now it's letters. Do you think we'll get the same thing? We do, we get true. So basically, as long as anything is there, it will basically evaluate to true, as in like this exists, this thing exists. So if there's something there, it exists. Now, this right here, 2 quotes, is a string. It is a valid string. Let's see what this is. This is false. So basically, for a string to go to a Boolean, if there's any data in the string, if the string has any, you know, characters, any letters, it will always evaluate to true. If not, it will be false. If it has nothing in it, it will be false. It's a tough concept. Sometimes as you're going through, it's something that'll trip you up throughout your coding career. But yes. So we just learned real quick that we can, you know, we want to see what it looked like. Casting, you can cast from one type to another type. That's the important concept right here. Yes, it is important if you're trying to learn how to code that you need to learn how to do it in the whatever language we're talking about, but that's not the goal here. That is something for you to do kind of after this. Hopefully I'm going to push this code for you to follow. Try to type it out, try to follow along and do it right now if you can, but just know that you can do those things. Again, string to integer, it will allow you to do it. If it's a number, same thing to float, and it will allow you to convert to a bool. So you can in fact convert a string to any of those types as long as the case is correct. So now that we're done with the string, we're done with all of the string items. So now we're on to converting integers to other things. I'll stop there for a second. Any questions? I saw a lot of stuff in the chat, I thought, so let's see. Mr. Demon Wolf, what's up? How you doing? Thanks for the host. Why are there 2 variables? Yeah, just use 2 different ones to kind of to save the value of the change. So remember I said that casting, it doesn't actually do anything. Like if I do int, let's say there's a variable of age, and my age equals, again, 40. I'm not 40, but say it's 40. And we cast that to a string. So you cast it to a string. This does not save anything. It will do this. Like if we print it out, it'll convert it for me and it'll print that value out. But age will still be 40. It does not change the value of age unless we save that. So like if I run this right now, you can see here, it prints it prints string 40 because we try to turn to a string. But age is still 40. Was that what I was trying to do? Age is still the number 40. Age is actually still the number 40. So let's do type. So age right here is a integer. So right here, when it you know, it's an integer when it starts, we converted it here, or it looks like we converted it here. And when we print out the type again, you know, if this were to work, it should be a string now, right? Nope, it is not. It is still an integer because this doesn't actually change the value. It only does it right here. It does not change the underlying value of age unless we save it to something else. So if I wanted that to save, I could do this. But this is why we're using a second variable, to not make it confusing. But I could do this this will now change it. So now age is 40, it's an integer. We converted it to a string here and then saved it back to the variable age. And so now this will be a string. You can see here, class type is string. So cool. All right, so let's start converting integers to other things. So you've already seen that when you try to convert a string to an integer, it must be a number. The same concept applies here. And again, to do that is an integer. So we'll keep age 20. To convert it to a string would simply be str. and that's how you do it, and it'll convert it into a string. And this will allow you to, again, create a string out of it. So like we did before, if we wanted to print my age is plus age, it's gonna fail. It won't allow us, it's not gonna allow us to print that out because it can't add a string. There's a string right here, and this is actually an integer. It can't add those things together. It cannot concatenate those things. So whenever you want to use a number inside of your print statement like this, you can like you either have to interpolate it or concatenate it. If you want to concatenate, you have to cast it to a string, and now it can do it. It can put strings together if they're strings. So that's what happens here for that. So that will work. Same thing for float as well. An integer to a float, you can simply do age equals 40, and if you want to convert it to a float, you can do print float age. And so when you print that out, that's actually going to turn 40 to 40.0. Just going to add a .0 into it. If you don't add anything else, it's just going to add a 0 to it to make it a decimal. Floats are decimals, and it will allow you to do that. Again, it must be a you can always convert an integer to a float because integers are numbers, so you can always convert it to a float. But to convert to an integer to a string, you can also convert every integer to a string. You can convert anything to a string, and you can convert any number to a float as well. And so let's see what happens when you do a bool. You do age equals 69. That was, I did not do that on purpose. It happened, and I already know you guys minds are in the gutter because of the couch situation. But whatever, we'll run with it. You know, we're not afraid of risque topics like this. But if we want to convert this to a bool, what happens if you do bool age? What do you get now? What's gonna go on here? You get true. So 69, yeah, yes, this is true. All right, but so is 70. So, you know, don't, you know, it's okay. So 70, also true. What is 0? What is 0? 0 is false. So remember how we had an empty string? That was false. So is 0. So basically, if there is symbolic value there, then it is true. If not, it's false, because we know that 0 is a number, but it is a false value. So you can in fact convert an integer, any integer, into a Boolean. Let's go negative. Let's go negative and see what happens. So negative 20. What do we get here? Is that true or false? And that is true. Again, any perceived value other than 0 will in fact be true. So cool. Now that we're past 69, let's keep going. Now we're on floats. So floats to string. Like I said, anything can be converted to a string, really. Account. Let's go price. We're gonna stop calling me poor for a second. Not Prince, price. Let's say the price of something is $4.99, which is in fact a float. That's a decimal point. It's a float. Let's try converting that. Let's try printing out. What are we trying to turn to? A string. So str is how you convert something to a string in Python. If we try to convert that, can we do it? Does it in fact work? Yeah. Yes. It just prints it out as is. No big deal. Like I said, everything can be converted to a string, basically. So that's never a problem. If you want to convert it into an integer, though, what do you think is going to happen when we try to do this? And actually, I should just copy this. I can copy this to all of them because, one, in my mind, because I'm usually doing Go, I was like, oh, I can't just copy and paste over and over again because I'm reusing variables, but that doesn't matter in this language because variables can be changed. So it'll just change the variable as we move along. So price equals $4.99. We'll print it out. We'll try to convert it to an integer. Let's see if this is allowed. Can we do this? Yes, we can do this. It does, in fact, simply strip those things off. It strips off the number values. Now, that can be pretty dangerous. No, but it does, in fact, no matter what these are, it will strip them off. It is not rounding. It is simply stripping them off. So no big deal. What's up, Jump Ship? How you doing? To concatenate the data types need to same yeah, like, so concatenation is only strings. So to put, like, concatenation means putting strings together end to end. You can't concatenate any other data type. You have to convert it to a string to concatenate them. So it will just strip it off. It is, again, like I said, it's not rounding or anything like that. So you can convert a float to an integer, no problem. In Python, this is, so these things are specific to Python. They will act differently in other languages. Just to be clear, a float to a Boolean. So price equals $4.99 and print bool. Let's see what happens when we try to do this. And maybe you're probably thinking it's going to be just like the integer, because floats are numbers as well. And you would in fact be correct. So you have true, no matter what we change it to, even if the price is negative $4.99, we will still get true. But if we make it 0.00 our price, it is in fact false now. So remember that empty value is pretty important, and we're going to talk about empty values in a little bit. And then the last set, let's try to convert bools to something. So broke equals true. We're gonna go back to calling me broke, that's fine. And let's try to convert that. So print, what are we trying to do first? Convert it to a string. So how do we convert to a string? str. And let's try to convert that, convert broke. What do we have here? What are we gonna get? We get true. Again, like I said, you can convert everything to a string pretty much no problem. It just prints out the string true. But what if you try to convert it to a Boolean? What happens if you try to convert it to a to a Boolean? And also, don't feel like you should be remembering what's happening with each of these cases. Not important. This is just practice with it. This is just like, you know, this is exploratory. Like, this is like, yeah, we're kind of, you know, we just got a shiny new car, and we're just looking around, you know, looking inside of the glove compartment, looking inside of the bin, you know, the little center tray, and like, you know, seeing how far the seats go back and forth, messing around. Like, you can always practice with it later. The concept is what's important. We're just having a little bit of fun with it. All right, so what happens when you try to convert a Boolean, a true or false value, to an integer? So I need to change this to int. Whoa. 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 All right. Try to convert it to an int. Look at that. We get a 1. We get a 1. That's really weird. That's weird. So we make it false. The only other Boolean option is false. What happens when we do that? What do you think it's going to be? False must be 0. Perfect, Sean from LA. Absolutely. Is there a use case of converting a bool to a string? Yes. Yes. Usually it's for like outputting information. Like maybe you're using that Boolean value to, you know, process things in your code, and then you can use it at the end to say maybe like give some output to the user, or maybe in your logs say, hey, you know, this did not work because this value was false. So yes, there's a use case for that. I've seen it be done before. Okay. So true is 1. True is 1. False is 0. So this is kind of going back to your binary stuff a little bit as well. It's two states. It's very much binary. It's two different states, true or false, 0 or 1, on or off, and they represent that value right there. Okay, and this is the last one. The very last one we have is Boolean to a float. Let's try that again and see what we get. And what do you think we're gonna get here? If we just got 1 and 0 for integer, what do you think we're gonna get here? We are probably gonna get 0.0 instead of just 0 because it needs to be a float. Float is a decimal, and you know that makes more sense if we change it to true. Hopefully you're following, and now you know you're gonna get that sweet 1.0. All right, so we just did a lot of casting here. We did every example. I actually didn't intend on doing every example in the beginning, so we did a lot here. I'll uncomment that stuff and put this up just as examples if you want to play with it. If you just want to look at it, something to reference. But the important part is you know that you can cast data to a different type. In programming languages, it's done in different ways. It interacts in different ways, but play with it, see what you can do, see what you can't do, have a little bit of fun with it. Just know that you can do it. I kind of want to show you, I do want to show you Go a little bit, but we're not going to because it's going to make it a lot more complicated. Go has the parameters for doing that. You know, to do strings is one package, and do integers another one. And it's a bigger thing. Not important that we cover that right now. You know that now you know that you can cast types to other types when needed. All right, string methods. This part's fun. Actually, let's take a little break here. Let's ask some questions. Let's have some questions. Let's, you know, ask your questions. We'll take a break here. We're still good. I think we only have like this is actually math operators. We'll cover it real quick, but not in depth at all. I think this is actually covered also in the operator section, which is I can tell you exactly which day since I shared it now. The operator section is curriculums, decoded, aprendes. Operators is class number 7, so Monday of next week we'll cover that again. So maybe we'll go slow. Well, maybe we won't get deep into that, even though it's for the most part straightforward. So just 1, 2, 3, 4 slides, but these two are kind of they're similar. All right, let's do this. String methods. This is fun. This is where you get to do a lot of cool stuff. So head over to W3 Schools. I'll copy this link address. All right. Go is unnecessarily hard. The irony of his name. It is so it's crazy because it's not. Remember that chart? Actually, this is like, so you say Go is unnecessarily hard. Remember this? Decoded number 1. Scroll down. Remember, come on, I know you're here. Load up fast. Remember this chart. Check that out. You all say Go is unnecessarily hard. Look at this. Fast and fun for humans. Look how high up this is. This is really high up. It's really high compared to these. Look at these. So if you like, I hear you. I definitely hear you on that. The syntax and like it does seem a lot more complicated, but again, there's a big difference in the rule sets, and this is why I said in the beginning that like I find that people who learn dynamic interpreted languages first, when they try to move to a static language to try something out, they have a really tough time because of the syntax, because of the amount of extra rules. So this is why I recommend kind of diving into them in the beginning together, just to at least be familiar with those rules. You don't need to know them, but like to be familiar with them, because it is a relatively big jump from here to here. But look how much higher this is than these. Like it really is. Like it looks like a lot. It is actually like pretty fast and fun for you to write. Like it's actually pretty nicely written compared to these. Yeah. So just showing you the extent that it goes. Go check out someone writing some C++. on here. There's people writing C on here all the time. Go check it out. You're gonna be like, this is ridiculous. Like this, I still feel that way, and I know Go pretty darn well. And whenever I see C++ and C, I'm like, I understand what you're doing, but like this just doesn't seem fun at all for anybody. So I don't know, just some context there. With string methods, everyone head over to that link. I pasted it up. This is great. So most languages have a way for you to have some fun with strings, and it's really not for you to have fun. It's for you to do cool things. Methods, we're gonna learn about methods later, but they just have some cool things you can do to easily change strings. So maybe you want to capitalize the first character, or maybe you want to center a string, or count the number of times something is in the string, or maybe you want to I don't know, capitalize the whole thing. Maybe you want to determine if that has a digit in it. Maybe you want to, there's a bunch of stuff. Maybe you want to make it lowercase. There's a lot of options here for you to do that. These are called string methods. These are ways for you to play with strings. The reason we're learning about this tonight is because, again, we're learning about data types. And when we learn about data types, we want to learn about what we can do with those data types. Like if there's different types of data, that must mean we can interact with them differently. And that is in fact the case. You're allowed, you can do cool things with data. So let's practice, or let's play with some of these. They're not called string methods everywhere. They're called string methods here because these actually are things called methods that are on here. Methods aren't always the way that you do this, but again, Go has ways for you to do this stuff as well. Not quite as many because Go tries to give you the bare base level of tools, but let's try some of these cool things out. So let's make a new file. Let's close casting. I'm not gonna say both words because I might get banned from Twitch for this. So let's touch what are we calling this? What are we doing? We're doing string methods. So let's call it that. Let's call it string dash methods.py. So I'm gonna call mine. You call yours whatever you want to. Could you show us how to see those methods in Python itself? Like in the documentation? Not yet. Oh well, fine. There's a couple different ways you can go see it. There's official Python, like you want to actually see how they're implemented. Like you want to see the method code itself. Is that what you're asking for? Like you actually want to see the code from Python standard library. If that is, let me know and I will show you that. But I'm going to show it to you after we go over this so that people aren't confused and trying to go in and actually see the code for that, because it's just not necessary. But the nice thing about W3 schools, you should bookmark this site. 100% you should bookmark this site. This site has a lot of great references for you to easily see some of the stuff that you want to do. So if you want to learn how this works, converts the first character to uppercase. Fairly self-explanatory, but you don't know how to use it though. And you can click this and it'll give you some dope examples. I mean, when you run Python, yeah, if I understand what you're saying, then yes. Yes. I said, I call this one a string methods.py because these are string methods, but strings is fine. Whatever helps you remember. I just call it string methods because we're on the string methods section, but call it whatever you like. But it gives you an example here. So check this out. Uppercase the first letter in a sentence. So look, let's break down the examples. And this is this is actually a great way to start learning code as well. Like looking at code that you did not write and seeing what's happening. So you might say, hey, I have no idea how to use this. They gave me an example, but like maybe I don't know how to read this. So they set up a variable. You can see here, there's a variable. We know this piece, and that variable is a string, and we can tell it's a string because it's got the quotes here. It says, hello and welcome to my world. All right. So we can break down this line and we can understand what this line means. When we get to the second line, and it might take a little bit for us to figure out what's happening here. So they say x equals text.capitalize. Well, we know what the initialization of a variable looks like, which is done here. So it looks like we're setting up a variable called x, and we're setting it equal to whatever the heck this is. And this right here is the string method. So it is, we're using the capitalized method on the string text. So you have to do a string method on a string. The data type has to be a string. If text was equal to something else, we would not be able to do this, but it's a string, so we can do the string method to it. So text dot capitalize. So this is the way that you run one of these methods. It's a dot, the name, and then there's these open and close parentheses here. And then they said print, go ahead and print out X, and we can see what that looks like. So let's go ahead and do exactly this. I really like this. Let's copy and paste it into our own code, because I think it's more fun to do it in your own code. So let's open up string methods.py, paste that in there, or type it in or whatever. So got some text here. We run the capitalize method against it, and we're printing that out. So now let's run it. Python 3, I call this string methods.py, and this is what it prints out. And look at this. This is different. It looks the same, but the H here is capitalized. All right, capital H. The capitalized string method capitalizes the very first letter in the string. So no matter what we put here, you can change this, even if it's already capitalized. So maybe if I put hello everyone, this is going to be fine. It's going to work, but it's already capitalized, so it's fine. But no matter what, it's going to make sure, it's going to try to capitalize the first letter in this. What happens if it starts with a number? What happens if it starts with a number? Let's see. Nothing, and nothing will happen because it's gonna do its best to capitalize the first character in that string. The very first character in the string, it's gonna try to capitalize. You know, if it can do it, great. If not, you know, oh well, it tried. It did its best. Welcome to my world, baby. Why would you do that? Why would you capitalize this? How it is efficient to do this way? So the reason you might want to do the capitalized method, again, more for output. Maybe you are maybe you're processing a bunch of data and you are taking data that's given to you and you want to, you know, deliver it to someone. Maybe you're trying to put together a sentence. You're trying to build a sentence on the fly or something. The capitalized method would allow you to easily just make sure the first letter is capitalized, because that's common. That's a common thing. Do two sentences, please. Do you mean two sentences right here, or two different variables? Do you mean two different variables? So like, hello everyone, comma, like mine, like this. There's still one sentence. Do you mean like this? So like everything in here, like everything that's in the quotes is going to be seen as one sentence. It's going to be seen as one string. Everything, and you can only set this equal to, you know, one set. If people are entering their names in a text, oh yeah, like if people are entering their names into a text box. So you can also use this stuff to sanitize data, and that's exactly what MGene is talking about. It's like, let's say, yeah, I had a form, maybe I had a form or something, and people were putting, like, they could freehand put in their names and stuff, and maybe to make sure the data is like consistent and clean and reliable, or you're displaying it somewhere else, you could run this capitalized method on it to make sure that everyone's name had a capitalized first letter, so that everything looked good. So hello, oh yeah, so even things like these periods, it's not a new sentence. This is still one string. It's all just a string. These are all just characters within a string. So same thing, it will not whoa, oh, I didn't know that actually. So it doesn't matter about this. This is good to know. It doesn't say this though. It also lowercases everything else. This is interesting. This is not something that I knew. Learned something new today. Check this out. Look what it's doing. It is capitalizing the first and lowercasing the rest. That is, I did not know it did that. Cause look, check this out. Even the definition of it doesn't say that. This method returns a string where the first character is uppercase. That is that's ridiculous. It's not ridiculous, but this is what the definition is. This is what I've always known it to be. I've always known it to be that, but it looks like it also lowercases everything else. That is very interesting. That is very, and so, okay. So, and this was someone's question earlier. Who was that? Was this AJVN? This is how you can see what it's doing. So if you really want to like know what it's doing, once you get further along, you can right click this and click go to definition, and it'll take you to the actual code that is doing this. So like this is actually what's happening. So if I wanted to confirm that it should be lowercasing everything else, I could go through and I could read this. And I could see, I could follow it and see what's going on. It's a lot. I don't expect you to know how to do that at all. But that's the way you can do it, because that question was asked. Did anyone else know that though? Did anyone else know that it lowercased? It lowercased everything else? Because I did not know that. I didn't know any of this. Cool. Okay, that's something that I learned. Let's go ahead and put that in our what we learned. Python capitalize string method, down cases everything after first letter. Yeah, didn't know that. Appreciate that, Angus Red. Appreciate that. That should be clearer. I do agree that should be clear, and maybe it is clear. Maybe W3 Schools needs to update their information. Maybe Python capitalize, string capitalize, Stack Overflow. I'm gonna see if it in Python, capitalize method converts the first character to a string to a capital letter. If the string has its first character as capital, then it returns the original string. Yeah, maybe I'm doing something wrong, but maybe I'm doing something wrong. Am I? Like, hello everyone, my name is Aaron. I run into the capitalize method, and when I do that, it lowercases everything. So I don't know what's happening here. Didn't know. Okay, this implies every other character is not capitalized. Sure, okay, that makes sense. That's something I learned today. But these are what these methods are. So now that you know how to use one, you can just take this and you can go back to W3 Schools and you can look through this list and you can try some of them out. So the problem is some of them take in information, so you may not know how to use those. But there are a bunch of them. So maybe we can check if all the characters in text are digits. So it gives us some cool ways to determine whether or not a string that was given to us is a digit or not. Where would you want to use this? This is interesting. There's a good place to use this. Well, let's try this. So let's change this to is digit. Save it. And when print it out, it returns false. So it's false because all the characters here aren't digits. But if we do all of these, we save it, it does return true because they're all digits. If we put a single character in here that's not a digit, it returns to us false. Why would you want to do something like this? This is a good one. Why would you want to, I didn't do string that upper yet. I'll do string that upper in a second. But why would you want to do something like this? So, remember we learned how to do output and we learned how to do input. Check this out. Maybe I want to say input. What is your age? Question mark. Question mark, space. Maybe I want to check what your age is and I want to save that to text. So txt equals input of this. Before we even do this, let's check this out. Let's check what the type of text is. Type, so Actually, I'm gonna do it in the new way that you all taught me. I want to practice the things that I learned. Colon close type of txt. I think that's how I did it. So if we want to check what type text is after an input, let's run this code real quick. What is your age? I'm 546 years old. And when I hit enter, look at that. Even though I entered in a number, I didn't put any quotes around that. It says it's a string. Input is always takes in a string. It's always a string unless you tell it otherwise. I could actually convert this into an integer, but maybe that's what you want to do. Maybe like you're checking for something, maybe someone's putting in a number and you want to make sure, you want to validate. Maybe I want to say, just to show you, I'm going way ahead of what you know, but maybe I want to say, like, I can actually check. I'm not gonna actually do the code for this, but like just to show you what kind of logic you can do in code, maybe I want to ask someone for their age, but if they don't give me a valid age, I might want to, you know, not accept the entry, but I could do some validation that says, hey, if text is digit, if text dot is digit is false, equals false, like do something, say hey, you can't enter that, please put in a number. Now this is not real code. I started to write real code and I stopped, but that's the kind of logic you can do. You can kind of check for these things. You can say, all right, check if this thing is a digit. If it's not a digit, they'll say, hey, you're supposed to give me a digit, try that again. So that's just kind of the starting to give you the things you can do with some of this stuff as we get farther along. Just start thinking about it that way. Can we convert the input type on the fly? Yes. So look, if you want to convert this to an integer, you can cast it right here. You can cast it and capture it right here. So if I want it to be an integer, I can do that. And this will save you from having to write the code that I was just talking about, because if I enter 546 again, it's a type int. But what happens if I type in some letters? You get a whole error and the application breaks. So you get a little bit of your validation right there. So yes, you can cast right up front, but let's just play around a little bit more with these string methods. With the methods, so we did is digit. Let's try the uppercase and lowercase. That's commonly one that people use to. We talked about sanitization a little bit, but there's an uppercase and a lowercase. And again, I encourage you to just read through these, try them out. It's a fun thing to try out, see what happens, see what doesn't happen. See if you're trying to run one and you can't get it to run properly, start doing some Googling, start going down a path and seeing what you can learn about that. But dot upper or dot lower is a common one. Dot lower is probably a little more common, to be honest. So it either converts it all to uppercase or all to lowercase. So let's maybe say, you know, like what is your, well, let's just, text is there we go, and let's put in some capitals there as well. And x equals text dot lower. If I print x, this will make everything in here lowercase. Oh, okay, because it's a string object. Actually, no, it's because of this. I hate when the objects in Python confuse me sometimes. And check that out. No more uppercase letters in here. Or I could change this to upper. Again, we talked about data sanitization. Why would we want to do that? We want to do that. Whoops, I don't know why I uppercased all that. You know, that was my mind naturally doing what the word was. That was really weird. But why would you want to do something like this? Remember that ASCII table we talked about. Remember that a lowercase a, because of that ASCII table, because of the way data is encoded, a lowercase a is not the same thing as an uppercase a. They're not the same thing. And so different programs and different processes, when they're doing comparisons, Aaron, depending on the language, may not be equal to Aaron. So maybe if you're doing some type of, you know, checking and you're doing some type of processing, it's very important that your data is like you know what you're looking for, and things are important, and the way that people enter stuff, and you know the way that it is coming in. There's a way to normalize your data and to make it in a consistent format. So you might uppercase everything. I wouldn't uppercase everything. You'll probably lowercasing everything. But it's a super common paradigm to do that. Like this is like very common to lowercase stuff to make sure everything is in the proper format. So yes, Aaron does in fact, lowercase Aaron does in fact equal lowercase Aaron, but uppercase Aaron is not the same thing as lowercase Aaron. So that's pretty cool. And then yeah, is digit and stuff. Check these out, try these out. String methods, again, what we care about is, now that you know what strings are, just understanding that you can do some cool things with them, that there are tools and tasks and resources and functions and methods that you can do to strings only. What happens if I try to do one of these to a non-string? What happens if I make this the number 67, not 69? What happens if I try to do this? It fails because string methods can only be done to things that are of type string. Cool. All right, so we're done with string methods. Let's move on to the next one. Mathematical functions. We're not going to care about that. We don't care about this right now. I'm actually going to do this along with, I'm going to do these two in the operator section, but there are also functions the same way we can do stuff with, the same way that we can do things with strings, we can do some cool stuff with math as well. So for integers and floats. So maybe you want to round something up, like a float upwards. You can do some stuff, round it down, or find absolute values, or add things together. So that stuff's cool, but we're going to learn about that in the other section. Let's talk about this a little bit now. When we're talking about integers and floats, you can do math operators. So the things that you see on a calculator, you can do these things. You can add, subtract, multiply, divide. And let's talk about these last three really quick. So modulus, this is a pretty important one. Actually, let's see us do all those things first. So I'm gonna go into the Python interpreter down here. So I'm just gonna type in Python 3. So now we can add. So 5 plus 5 does in fact equal 10. So the way that you do addition in Python, if you need to add two numbers together, you put a plus in there and it will add two numbers together. What happens if I do 5.5 plus 5? We do in fact get 10 and a half. So it works like a calculator. Everything looks good there. Same thing for minus. 10 minus 3 is going to give you 7. The spacing doesn't matter here. So you can subtract, no problem. You can multiply. So multiplication is using the star. The star will give you multiplication, and you can do that. Great. Times 30. So you don't need to know how to do any math here. And you can in fact also divide. Check that out. 10 divided by 3, 3.333333335. Great. So you can do the basic math functions, or the normal mathematic operators that you know about. You can do those. Now, real quick, we're gonna talk about modulus or modulo. This is division. Modulus is division. So right now, just now, we did 10 divided by 3. So it's gonna say, how many times does 3 go into 10? And it goes in 3 times, that makes it 9. And then it goes in, 0.333333335 more times. So, a portion of 1, 1/3 of 1, basically. Modulus or modulo does division as well, but instead of giving back the actual value of the division, it divides. So it performs the same mathematical thing here, but what it gives you back is the remainder and not the actual division value. So if I do this, and so modulo or modulus is a % sign, if I do this instead, I get 1 instead. Why do I get 1? Let's take you back to 4th grade math class. Again, 3, how many times does 3 go into 10? 3 plus 3 is 6, plus 3 is 9. So it only goes in completely 3 times, and it has a remainder of 1. So to get to 10, there's 1 left over. So modulo or modulus returns the remainder. Okay? it returns the remainder here. So let's do 10 modulo 4. What's 4 gonna give us? How many times is 4 going to 10? Well, it goes in 4, then another 4 is 8, so it goes in twice, but it can't quite go into 10 a third time, so there's 2 left over. All right, so that's what we get. So 10 divided by 4, or 10 modulo 4 is 2, but 10 divided by 4 is 2.5. So again, it goes in 2.5 times, but modulo returns the remainder. So that's pretty important. And then increment and decrement. So the reason why we weren't going to talk about these until later is because you can't just use these. Like I can't just do like, I don't think you can. I don't think I can just do 1 plus plus. Like these are expressions. These are expressions, and there are certain situations in which they can be used in. But all you need to know right now is that plus plus means add 1, and minus minus means subtract by 1. But yes, it is wrong. There's no 5 at the end. I was just reading off the numbers. There is no 5. I'm not sure why I put that there. Probably some weird Python thing. Yeah, it's probably some weird thing. But yes, increment, whenever you see plus plus, it means plus 1, and whenever you see minus minus, it means subtract 1. Literally 1. And so when we went to the other slide, do I still have it up? I don't have it up still. But when we're talking about on here, let's go back to this again. This is where C++ comes from. So C was the original language, and C++ is supposed to be like 1 up. It's supposed to be like an upgrade. It's supposed to be like increment by 1. C is great. C++ is an increment by 1. So just a little bit of a background. C# is still debated on whether or not that means C+++++. So like, you know, a sharp, you know, ampersand is really 4 pluses when you look at it. So people have kind of debated like, oh, is it supposed to be like +2, like plus 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 plus? Interesting. But yeah, that is what the increment and decrement is. Add 1 and subtract 1, and we'll go over that later at another time as well, because they operate in a different paradigm. They're expressions, you can't just use them. So yeah. And the last 2 things, right on time, there's empty values and there and 0 values. These are 2 different things. They are 2 different things. So let's talk about these 2 things really quick. Does anyone have any questions? Could we use modulus in case we need to filter only even numbers from an array or something like that? Yeah, yes, 100%. Yes, you could absolutely do that if you wanted to do that. That's the best way. That's the best way if you want to do it manually. I think there's some other ways to do it that Python may give you. But yes, and you know what? I'll show you because I do think that's, you know, take you a little past your comfort zone a little bit. How would you know if a number is even or odd? If you want to check if a number is even or odd, maybe text equals 67, right? And so you know a number is even if what? If it is evenly divisible by 2. So I can do something like this. And again, I'm going past your comfort zone. Don't sweat it. It's just kind of expanding on that modulo concept a little bit. So I could say if 67 modulo 2, or if text modulo 2 equals 0, that must mean number is even. Number print text is even. If not, it must be odd. If it's not even, it's got to be odd, right? And then so I'm gonna say else print text is odd. And now we've written our first program that can tell us some information. Again, past your comfort zone, don't need to copy it. I just want to show you that modulo is kind of cool to do stuff like this. Any number divided by 2, evenly divisible by 2, is even. So modulo, because modulo 2 returns the remainder, because if you have something that's only going to check for the remainder of something divided by 2, if it is 0, if there's no remainder left over, then it is evenly divisible. And so now we have a cool little program that will check if the number is evenly divisible by if it's even or odd. And so this should be odd, right? So text is odd, but if we make it 68, text is even. You can keep going up. Pretty little fun, interesting thing. But yeah, modulo is cool for stuff like that. The very first algorithm that we do on here together will be using modulo. We're doing a modified version of FizzBuzz first, but again, just because FizzBuzz is always a hot ticket item, just because of what it is, and it's a good approachable first thing that teaches you a lot of stuff. But yeah, no big deal there. And all right, the last two things: zero values and empty values. Two different things. Let's share those real quick. Empty values are the lack of things. Now, there are different languages handle these completely differently. So it's important to, right now, not to start to fit in any specific ideas about empty values, but empty values are not, they're not zero values. So zero, the number 0 is not an empty value, it's a value. What would there be if this is if there was no value there rather than 0, or rather than false. So but again, different languages handle this differently. The common empty values are none, nil, or null. Python uses none. Python has a none type, has a whole type of none. Go uses nil. Python might also use null, but it's just something to know about, that there is a value, like there's a state in which something doesn't exist, and that is different. There's undefined as well. I don't know why I didn't put undefined in here. Let's put that in here. That's really important. And something like JavaScript, there's undefined in a lot of languages. So this part is very important. It's very, very important. Undefined, nil, null is not always equal to something like 0. So just know that there are empty values. And the very last thing is zero values. So we'll do like this is a good little thing in Go. But what if something exists, but its value is of 0? So each of these data types has basically a it has a state of 0. It has a state of existing, but being the equivalent of 0. And so these things are called zero values. And so this is a little example in Go here. So you can kind of click it here. And so when we basically say, like right here, we're declaring a variable, but we're not setting a value. So we're saying, hey, we have a variable called I, and it's an integer. So when that happens, when you set that up on a computer, because you can kind of initialize that variable, but not you can declare that variable but not give it a value. What is that value? Like if I made space for it, what is the value? If I try to use it before I give it a value, like what is it? And that's what this will show us. And if I click run here, the 0, and this is just in Go, and different languages this is different. The 0 value of an integer is in Go is 0. The 0 value of a float is also 0. The 0 value of a Boolean is false. And that makes sense because you saw that, when you try to convert that, 0 is false. The 0 value of a string is an empty string. So you can see these quotes right here. So let's see that in Python real quick, super fast. We'll do the same exact thing. Yes, this right here is conditional logic. We will get there in week, what week will we get here? We'll get to conditional logic we got to it right now, but we'll actually be learning it in operators. It's actually in operators. The conditional logic is actually a part of the operator section. So Monday of next week, we'll be learning with those if statements and stuff, because we'll be learning about things like greater than, less than, double assignment operators versus some of the other ones. So we'll be learning about that here. actually, I'll put it in there so it's a little more easily understood. That's what we'll be doing this week. Operators plus conditional logic. And you need to know the operators to know the logic. All right. So let's do the last piece. So string methods, let's actually go way back to what it was. Yeah, let's do this. So that when we push this code, you have some examples in here. All right, and then the last one we're gonna do is we're gonna create a little file, and we're gonna check zero values in Python. Actually, we can do that. Now let's make a file. Let's make a file real quick. So let's make a new file and call it, I'm gonna call it 0.py. I'm gonna open up 0.py over here, and let's try to do the same thing. So I'm gonna basically create a variable, but in Python, Python is a little bit different actually. Python, this is not gonna work the same because you can't, Python, you can't declare a variable and not use it, I don't think. So in this case, the zero values are the same thing. Really, the zero values are the same thing here. And this is this actually might not be a concept that lives in an interpreted language like this, because well, at least in JavaScript. So you know what, we're learning other things, so let's grab a different language. So Python, this won't work, like I said, because you can't just declare a variable, but something like JavaScript you can. So I'm going to touch a new file. You don't need to do this. 0.js. And so JavaScript, I can do something like this. I can declare a variable in the same way. So I can do a let age, which is supposed to be a number. And if I print out what age is before I like give it a value, node 0.js, we can check the whoa, my computer's like dying, or my VM's dying. Node 0.js, this actually fails. Cool. Interesting. Print age, print is not defined. Oh, we're in a different language. Console.log. Let's see what the zero value is here. Undefined. So the zero value in other languages may be different, like I said. So I set up the space for a variable called age, and when I try to print it out, I actually get a none type. This is actually different than the zero value. This is actually a none type. It's non-existent, and so it's important to know those things are different. But you know, it's yeah, it's a thing. It's a thing. You don't need to know JavaScript for this. Just in Python, again, like I said, I guess interesting. You can't just declare a variable, so it's going to be hard to show what the zero value is. But zero values are a thing. So in especially in interpreted language, I mean statically typed language, you set up something, the value that it gets by default is that zero value, and this is kind of just that default value. So this is commonly what they are, though. It's commonly something like this, you know, zero for integer. For numbers, it's the number zero is the zero value, which makes sense. For Boolean, it's false, and usually for a string, it's an empty string. So just something for you to know about. And that's everything. Oh yeah, y'all had me on the console log. You know, you guys. I mean, y'all are smart, man. I get there. I mentally walk myself to the place I'm supposed to be. You know. But cool. That's everything. That is everything for tonight. That is Dank DataTypes here. What are the tangible takeaways for tonight? The tangible takeaways are that there are different types of data that you can interact with in programming languages that operate in different ways. The common types, the four common data types that we really care about are integers, which are numbers, floats, which are numbers, but they're decimals. You know, integers are those whole numbers, both positive and negative. Booleans, which is true or false. And what is the last one? I'm tripping. The last one is strings, which is letters, which is a list of characters. Think words and phrases. Also think those double quotes for that. We also learned there are more data types than that, but these are kind of, there are like these are kind of the main ones we need to care about right now. There are more data types than that. We will be working with more over time. And so I gave you some more of those options. Go take a look at some things, watch some videos. I included a video from, again, that Harvard CS50 course, which will give you some information about some additional data types, but just be familiar with them. Cool. And we also learned that we have a tool available to us in each language to check what kind of data type a piece of data is. So if we ever want to know, we can find out what type something is. We learned about typecasting. We learned that there are times we need to change a data type to another data type. And so you can use typecasting or type coercion to kind of force one data type to be another data type. And again, there are situations in which that works and situations in which that does not. We also learned that about string methods. So we learned that we can do some cool things with strings, that particular data type that allow us to do some cool stuff. We know that we can go to W3 schools to go through and test out some of those things to be able to capitalize or lowercase, or or you can actually split words up, all kinds of stuff. So take a look at those, have a little fun with that. There are also math functions that allow you to do the kind of similar things that you can do with string methods. You can do some cool stuff with numbers as well, but we're not going through those tonight, like in depth. But there are some cool things in Python that allow you to work with numbers in some cool ways. We learned that you can do math in Python or in languages, period. Addition, subtraction, and these are kind of across the board. Goes the same way. Addition, subtraction, multiplication, division. We also learned about a concept called modulus or modulo, and that is where it's division, it's dividing, but it only returns the remainder instead of actually returning the result of the division. Pretty important. It's very commonly used. It's very commonly used across the board. And yes, that is available in Go as well. Pretty much every language has modulo. We learned about increment and decrement, which is adding by one. The plus plus is adding by one. Minus minus is subtracting by one. We also learned a little bit about zero values versus empty values. Empty values being the lack thereof of a value of data, whereas zero values is kind of the zero default state for a piece of data. Two different things. So that's everything tonight. I hope you got a lot out of it. I hope that it was less intimidating than the last run, than last week. Hopefully it was easier to follow. I highly encourage you to play around with this stuff. You don't even need to create these files. You can hop right in your terminal, type in Python 3 and start typing stuff in there. So maybe I want to say x equals 5, and then I can say type of x, and I can start trying out things like that. And this is the Python interpreter, and it will interpret whatever Python code you type into it. So maybe you want to try that, but encourage you to play around. On Thursday, we are doing Danker data types. So data structures. So we're gonna be learning about data structures. I've had a lot of discussions with people about those data structures are in fact data types as well. These are something called primitive data types. Those are non-primitive data types, but they are also data structures. Data structures also goes deeper than what we're covering on Thursday, but we're going to be learning about how to different paradigms and ways that programming languages give you to structure data to work with them a lot more easily. So that's what we'll be learning then. Yes, to quit, to get out of here, that's a good thing. You type in quit, open parenthesis, close parenthesis, that'll get you out. Or you can do Control D will get you out as well, whichever one works for you. And then again, tomorrow we are back with Horizons. And Horizons, I'm never gonna remember all this stuff. I never remember what we're doing each week. Horizons, we are learning about load balancers and auto scaling. So we're gonna learn about how you scale up infrastructure in the cloud. We're gonna learn about balancing load between servers, kind of how you handle that. But let's raise somebody. Let's head over to someone. Thanks everybody for sticking around. Hope you enjoyed it. Let's see who's on. If you guys ever have any recommendations for people to raid, throw them out there. We're gonna raid someone smaller. as we did last night. Night, everybody who's signing off. Thanks, like I said, thanks for hanging in there. Hope you got a lot out of it. Have a good night, everybody. Who are we heading over to see? Learning how to parse Twitter API. That sounds interesting. That sounds very interesting. I'm trying to look at the titles and see what I like. I actually like that. You made muffins? What kind? I'm gonna meet my friends a little. What kind of muffins did you make? I'm a big muffins fan. You know, if you wanna to ship some off. Yeah, I wanna hit somebody smaller. I wanna hit someone smaller. Let's do actually, let's hit all F4. All F4 hangs out a lot in a lot of our streams. A lot of people's streams, period. Pretty dope. You probably seen his name in here a couple times. Let's head over to all F4. He's doing some Node, some JavaScript, some GraphQL, some TypeScript. So we'll head over there. So slash raid. What is this? His name's long. The alt F4 stream. That's not long. I just can't type. All right, y'all. Let's head over. Let's say hello. Thanks for another great stream. I'll see y'all later. We're heading over in 8, 7, 6, 5, 4, 3, 2, 1. Everyone have a great night. I didn't click the button. There we go.